Thanks, everyone. Thank you for having me, and thank you for sharing, because all the conversations we had starting Monday afternoon and yesterday were all very exciting. And I hope that with my talk, I'm not going to bore you, that you're going to learn something, and hopefully that we can also advance this stage. But first, maybe a quick word about myself. So, Antoine, I'm the COO, co-founder of Exoscale. We're a cloud provider, public cloud. But I'm an engineer, so I've worked in telcos for the first part of my career, and this is actually not the first public cloud I built. This is the second one. I hope potentially the last. Let's see. Before I dive into the topic, I need to go a bit through the story of the company and why this is so important for us today. So Exoscale, it's something we bootstrapped, a lot more than 10 years ago. So we're in Switzerland, but the product that we have and we're selling today is infrastructure as a service. I launched on the market in 2013, and we went throughout the years for this. So of course we are in a world with in which you see those numbers. They're not huge, but at the European level scale, they're starting to be a bit relevant. So some customers, some partners, and a nice team to power this. We are present in 8 data centers across Europe. So not this side, more the other side. So great focus on the what we call the DACH region, so all the German-speaking area, and then we're also progressively expanding towards Eastern Europe. As we speak, we are opening a zone in Croatia, so we'll be hopefully the first public cloud over there, because there's a whole bunch of markets that are a bit left over on that side. For those last 10 years, we've been operating on those 3 values. That's how I promote the company towards our customers, partners, when we talk about ourselves. Simple, of course. We have to be hyperscalers. They have 200 plus products. I have 30 plus products. So by design, I need to be much more simpler. I make this a value proposition so that customers, when they get to us, it's much easier to start. We make this much. The barrier of entry is way simpler. Scalable, of course, and safe. But scalable also isn't that a given now, because all clouds, I mean, it's what you expect. In our case, it's even in our name. And we have now all those base products, so infrastructure as a service, infrastructure as a service plus, so that customers can come. What happened? The top one, sorry. So that customers can compose their own architecture. So we don't provide platform as a service. We don't provide the super high, the top services, but still it's scalable enough. So that's a bit of a given now. So let's scratch this from our values. Not relevant anymore. Not a differentiating point anymore. Second aspect is that, like all clouds, we spent the last 10 plus years doing all kinds of security stuff. So I have more logos than you can think of, more certifications. Every year we're adding 2 new certifications. It's a mess. It's a full department doing this. And every cloud today is super secure. Like we have literally people on the cloud doing 24/7, watching over security. So the level of security we implement, you have to be a $1 billion plus company to get the same amount. Okay, so this, need to compromise and remove it. This is the new one that we are currently introducing to our market. So there's one which is trendy. We're switching from the safe aspect, you're safe with us, to the sovereignty. So we're deploying in more and more local regions, and we want to appear to those regions as the local regional provider. So in each location we go, each country, we want to have 2 data centers, so people can build something that's highly reliable, but still feel local to the country. The real new one, where we see the trend, is this last bit, and this is going to be then the rest of my talk, is sustainable. Okay, we are here for the long run, and we are in an industry where what we do at the base is deploying servers, not that green. I mean, it's a whole bunch of silicon infrastructure and etc. So how do we make this a bit more sustainable for our planet, and why does it matter? There's one big thing that's a bit of in the shadows still, but it's, again, we're in Europe, regulations happen, and this one, CSRD, who's heard about it? Who's implemented it? Not many. Okay, so it's not coming from the Green parties. Okay, everybody think it's a movement from Green parties. Not at all. It's more coming from the financial sectors, which have been asking a more transparent way and even playing field when they are investing on funds, giving loan to companies or whomever. They were thrown reports about, is this company sustainable, yes or no, that they cannot compare. On the financial sector, approximately everywhere across the world, you can really quickly get an understanding of the financial situation of a company by looking at 2 things. Give me your balance sheet, give me your P&L. That's almost standardized across the world. There are even international standards. It's called IFRS, if you comply with this. And every financial expert will be able to read this and draw its own conclusions. In ESG world, in sustainability, that doesn't exist. It's a mess. So everybody reports whatever they want, whatever they think is good. People do a bit of also greenwashing. So this is hopefully coming in force now, full speed. So it was the applicability was last year. The first obligation to report is actually, I think it's June 20. It's coming right now. If you've heard recently, there were discussions in the European Commission about, okay, this the law is going to be wiped out. Eventually not. It's just that there's an omnibus law, so a bit of a push towards less regulations and less administrative papers. But it's just the only thing that changes is that the floor for companies' obligation to report is going to move from 500 employees to 1,000 employees. Okay, so it might not seem as a huge change. It is, because the number of companies that will be touched across Europe will be smaller, but still, I mean, 1,000 employees and plus companies, there are quite a few. Okay, so first reason is CSRD, but also second reason is that there's customer demand. Okay, why do we need to communicate about this and do it the right way? Is because we're seeing on a daily basis those requirements coming from in RFPs and etc. And despite the big title and my background, I'm still an engineer. So what do we do if we want to tackle this problem as an engineer? First thing you do is measure it. Thank you. So that's what we started to do. So it's more than 2.5 years ago. Okay, we're going to this sustainability venture. What's our status? We were already doing ESG reports for many years. So with Ernst & Young as in the background, very boring, very Excel. But no, it was okay. Now let's look really at our data centers, servers. What is it that we have? Because there's also this. I talked about a bit just before, but The greenwashing part, which is also, by the way, going to be regulated. People are really turning this into a competitive advantage. So there was the no bullshit also aspect is also dear to me in that in this segment. So, have you heard about LCA before? Yes, yeah, cool. So this level of awareness already has made its way, but when we looked at how to measure it, there are multiple methods, and the one that we saw was the most complete, was to really look at the full life cycle of what we put in our data centers and what's used to make our products. So compute, storage, network, all those databases. So LCA or ACV in French, you look at everything from the raw to the disposal of your hardware and your components that are part of your products. And there's a full landscape. There are also ISO certifications now for this. There's but the one aspect that's really important, you know, when you buy an appliance, a fridge or dishwasher, you have those stickers on the door, on the side, that tell you, oh, this is a B, this is an A, and etc. So the industry as a whole, and with the regulators, so here the EU has come together and has, you know, defined, okay, with the state of the technology now, how are we going to calculate and account for the environmental impact of product A or product B? Okay, but how to do this in IT? Nothing existed until very recently. Hopefully, I mean, and for this I must say thank you to the French government, because ADEME, which is the so correct me if I'm wrong, but it's the French regulatory body that looks after environmental matters. They took the initiative a few years back to go and write the first product categorization rule for data center and cloud. So there was a first version that was drafted in 23, but it was very, very much focused on the data center part of our business. So from brick and mortar, really accounting for the tons of concrete that you put in your building, to the piping and all those aspects, but all the more IT part, and especially as a cloud provider, where our business is a multi-tenant business. So it's not that I can get the environmental impact of a server and then pass this on directly to my customers. No, usually on my server I have multiple virtual machines. And to make those multiple virtual machines, I have orchestration, I have monitoring. So I need to take shares of all this infrastructure that's around it, and also all the unused space that's, I mean, we can never use hardware 100%. We try to, that's capacity planning is where we strive to be good at, but it's unachievable. So this first version was lacking all these higher level aspects. So we had the privilege to be invited to be part of a group with other stakeholders. Here, I mean, some Scaleway was with us, OVH, some nice logos. So all these guys for almost 1 year were together to define the PCR version 2 for data center and cloud. So, and this, you can read it because I was downloading the PDF last night. So literally it was supposed to be out in January, but they finally released it. So now it's dated April 2025. So it's 82 pages. If you really want to track and monitor and do your impact assessment for your data center and cloud, this is the way to go. There's nothing better at the moment worldwide today, and the hope is that usually this is how PCR goes, that with this being the first establishment, and if multiple companies adopt it, then it will become the de facto standard and then be enforced by the European Commission as, okay, you need to report and you need to track, measure things using this methodology. So, okay, we want to measure. Now we have a methodology. Okay, how do we do this at scale? Because yeah, we just have it's not just a few servers, and also if you benchmark, so LCA versus what everybody knows and has been around for many years, so it's simple carbon accounting and also other methods of this. If you've heard about scope 1, scope 3, LCA is by far the most complete and advanced way of doing your environmental impact. So this was the obvious way to go. So after having found the right methodology, it was how do we implement this? We didn't do this ourselves. We partnered with 2 other companies, with school, to write something that's called Cloud Assess. Check it out, it's open source, but you don't have to use it. If you want to implement the methodology on your own, you can. But basically what it enables us to do is to write code, so express how we do our own internal recipe. So what do I actually need to create a VM that has 8 GB of RAM and that much CPU and stack all that overhead and put it into a nice YAML, fit that into the tool. So the way it works is I need my DCIM data, so all my inventory data is injected into the tool. I need this modelization data, so how it works, and I need, of course, usage data. So electricity, things like how many VMs, what size, who was doing what at a certain point of time. It all goes into the tool using this trusted library, which is the PCR I was just talking about, and outputs the multi-criteria impact assessment data that we were striving for. And this we do on a continuous basis, because all the methodologies before, they were, okay, you do it ESG, you do it once a year. What's my global impact as a company? But that's not what our customers are asking for. Our customers, they are billed by the second. They receive a monthly invoice with compute hours, with storage per hour, and etc. So they want to know, and they need to know, that the impact of load balancer that they had in Frankfurt in January was certainly different potentially than the impact of the same load balancer, but in another location. Not just because the electricity that we used there was of a different mix, but also maybe because the machines that we have there are not the same generation, not the same manufacturer, and have had a different lifetime in them. So quite complicated to do. So that's our way to address it. It has cloud in the name, but it can also be used so for infrastructure provider, but for anybody that sits on top. So you could very well use Cloud Assess if you're a SaaS provider, model how your SaaS is architectured, get the data from your the base data from your own cloud provider, and then add your layer, and then also output the impact assessment of your own customers if you wish so. How does it look like? So for us today, it's multi-criteria. So it means that we don't just report about CO2. You have the water usage, of course, that's also quite common in our business, but ionized particle. So if you use electricity that's been from nuclear plants, I mean, it's it has a very low carbon impact, but it has another impact. The exhaustion of resources, acidification of soils. I mean, when you do IT and when we pull those resources and those stuffs in our servers, all kinds of things happen. So we have up to 14 indicators that, I mean, this is only a snapshot, but customers can get this as a JSON and then do whatever they need with it, so that they can also decide, okay, what's more important for them? Is it carbon? Is it water? Is it so they have the full view. The way to do this, and here I'm going to come to the more call for action to this room, is it all comes down to the quality of your data. We have a good methodology now, which has been used and crowdsourced from a nice group of participants. We have a tool that we're gently scaling up, which is auditable because open source, so works for us and is starting to be adopted also by other providers. But it's only going to be as good as the quality of data that we feed it. So one of the big aspects, we all use energy for our data centers. So we've partnered, and actually we buy data from Electricity Map to get reliable information and daily information about, okay, at this point in time, how was the electricity? I was mentioning Frankfurt before versus Geneva. So we get this data in continuously, but we also need data about our servers, our hardware, CPUs, memory, SSD, everything. And this is where it hurts a bit more. So the best way we found today is also to partner with a company called Resilio. But why? It's because they provide a database with an API so that we can pull this data, because we need this very frequently, and add this into our inventory database. And that's where we need better than this than today. Why? It's because in the core principles of environmental impact assessment is, if you don't have a precise and auditable data, then you take the worst approach. It's always pessimistic. So it most likely what we use today and what we report is much worse than it is in reality. Because companies, manufacturers are already making progress, but it's just that it's very hard to get access to this data. The data is only partial. Most manufacturers provide CO2 data, but we don't know what it encompasses. And more importantly, it's often out of date. The latest hardware, I don't have the data yet, or it's deep into a PDF. Doesn't work for me. We have thousands of servers in multiple 8 locations, and we are adding more locations. So I need to be able to pull this. And so this is where I will maybe make a liaison with the talk that we had yesterday about from Proton and about the factory. Yes, I think now is the time to get more structured data into this. So it's really a call for cooperations, because we're not going to be, we don't just need the carbon footprint. We need to have this full visibility into, okay, what has been put into this hardware over time. Okay, but it's not a one-off. Sometimes a SKU, I mean, could have its technical data sheet, but also manufacturers sometimes change where they manufacture it. So it was manufactured in one fab, and then over 6 months later, it's in the other fab. I want to know, I need to know, if we want to be transparent, especially if that fab now is closer to me. It's going to be an improvement for the end customer. It's going to be an improvement for the citizens, that if the part now only comes from 1,000 kilometers away and not half of the world, this is something we can actually report and give transparency to our users. There's an opportunity here on the market, because already today, at the same price point, performance, if one company comes to me and provides me better and structured data about their LCA of a piece of component, I'll choose them, because it will make my life so easier, and because it will make my report and my environmental impact towards my customer better. Otherwise, I take the industry worse. And it's getting access to a whole market. It's not fully into force yet, because the first exercise of CSRD is only coming now. But this law is progressive, so it's going to get harder and harder over the next 2 years, I think. And people could say, okay, yeah, but it's only for big corporates and etc. But even if you don't have big corporates as your direct customers, indirectly we are all supplying to them, because maybe we supply, we have a SaaS, and this SaaS is used by one of those big corps. So there you have it. In the next years, the requirement will drop down to you. So this is really a need. I could have stopped on this slide, but as an engineer, while we were doing all this measure project and etc., I mean, something was scratching our head as well. So once we measure, once we give transparency to our customers, how do we actually get to go and reduce it? So especially when these things happen. So I didn't want to do a lot of name dropping, but here this is NVIDIA. So you see over time, you have more and more types of GPUs. So we need to deploy more and more types of clusters, and all those cards, for example, they consume much more. So it's a nightmare. It's completely going opposite direction towards what we want to achieve. So one way to do it, while we were doing this measurement project, was also, okay, let's try and see what we can do about actually can we get to a point where, even if we can avoid buying the silicon, even if we can avoid like having those large PCBs and all this metal, etc., and renew this quite often. What can we do at our little scale to make things better? So this is a bit the approach we had, that taking a step back and saying, okay, how do we cool this hardware in our data centers? So everybody knows, so 20 plus years back, data centers, we were all trying to cool the whole air in the room. So that's a lot of air that you need to cool. So not that efficient. Every data center now is in a model that's similar or to the one in the middle, where we have containment in place. So we're trying to cool a much smaller area, and this goes through inside the servers and then back. We have, and I didn't draw it here, but this middle, so we see all kinds of in-row or hybrid solutions at the moment, but we wanted to push the needle a bit further and say, okay, what if we would get rid completely of the ERCO? Because if we want to be really much more efficient, yeah, thank you. It's like an hybrid car. I mean, you need to maintain the two technologies, so electric and petrol. So why in our data centers do we want to, should we need to maintain air conditioning and also CDUs and water loops and etc. So that's what we try to do a concept of a cold box. And what we now have as a, we call internally a POC, but it's production for our customers, because they it's a GPU offering. So here we deployed in what was a storage room of a data center, completely isolated boxes, just like a fridge. There's foam on the sides so that we contain the heat maximum inside the boxes, and everything must be fully all the heat is dissipated through the liquid going into that system. If I open the door, this is how it looks like. So it's a first version. Don't mind the quite dirty cabling to my standards at the moment, but it works. So this box has 4 what you could call blades, and there are GPU blades. There's a number of innovations that went into this. One of them is so force ourselves not to use air conditioning, not to use copper. So all the water blocks. So here we have a water block and we have a GPU on one side. They're all made of aluminum because it's less expensive. That's good for finance, but also it's a fun fact. So when you start pulling, recycling copper possible, like all metals, but very much more expensive, especially in terms of energy. Recycling aluminum, 95% more efficient than any other metal. So we also forced ourselves to do aluminum only. And also one aspect is this hardware, it's those GPUs, this is PCIe card, so not the latest generation, and this is Ampere. But still, it's a bit of money. And there's one big fear is how do we, if some water and alcohol, so this is a system with a water plus 30% glycol. But what if there's a leak? So one of the small innovations in that system is that it's running under negative pressure. So if actually there's a leak inside the box, air will get sucked in, and no water will go out, and then until we can monitor and shut everything down. So we pulled that string as well, and then we're trying to make this a reliable concept. Because in the end, my dream is to get to this. So data centers today, they run with a primary loop, which is pretty cold. Why? Because of air conditioning. So you usually need to cool down the water to 16 degrees or so, and you get hot water, but which is not hot, 25 or so. Then you cannot do anything with this. What if, and especially using more DLC and 100% DLC systems like the ones we are prototyping, you could go to much higher temperatures. You could imagine 45, 50 degrees outlet temperature. And this starts to be energy that can be used in one way or another. So today there's the big fear that, and it's only just not only through just IT professionals like ourselves, but if you talk to the general public, they hear in the news that data centers are going to consume all the energy in the world and etc. I'm not so sure. I mean, we should be cautious, but we can go in and ride this AI wave if we do it smartly. Because so this is also at the European level how the population uses energy. Industry, big pillar, moving ourselves, and housing. And all the rest, including data centers, internet, and all, this is the smaller portion, okay? What if we just moved and IT was a byproduct for housing purposes? I mean, the 20% that are projected, that's okay, this is going to consume, IT is going to consume 20% of the world's energy, could almost be transparent. But for this, we need to up our game in the way we do cooling, so that we can use as less carbon, so also reduce the the materials and the exotic stuff, and have heat reuse capabilities wherever we can. That's it for me. Questions? Where's the ball?
Thanks, that was quite interesting. One of the things in sustainability, one of the things you have to look at is the duration of your hardware, the lifetime of your hardware. And if we listen to Jensen at GTC, his message was that from a tokens per second per watt, you need to re-up your hardware every year. I'm interested in your thoughts on this, right? Because that's in direct opposition to sustainability in many respects.
Yeah.
He skipped some parts of that discussion, by the way. He didn't talk about the cost of new hardware.
He does. So
it was only the operational costs, right?
Stay until the end, because this afternoon we're gonna give the feedback of a survey that we did from as the user group, and that was one of the points. I mean, it's where do we see the life cycle? I mean, 1 year, but this is an issue in the GPU market. The trends, and people are coming asking us latest gen, use it for the 1 year, and then usage drops, and then it picks up again. So today I still have in production P100s. The platform is full 100%. Because people have found usages, and today still makes sense electricity-wise to have those GPUs in production. And the only reason why it's getting harder is that you cannot get the software is not being maintained anymore. But I hope this doesn't come a reality. The 1 year fact is completely stupid.
Good rugby throw. Hey, Pete from Ampere here. Are you aware of a project called Scaphandra?
Nope.
Deep diving helmet in French.
Yes.
And it exposes joules over time information for virtual instances and also for containers now. And would allow your customers to do billing based on their own internal usage of virtual instances.
Yeah, there are a few projects like so. I don't recall the name of this one, but there's also KubeCost and etc. So for pure Kubernetes aspects. So I think there's a movement. I'll look this one up.
Yeah.
Thanks.
And just a shout out for a company called Gliosis up in Sweden.
Okay.
And they've been doing the concentration of heat, shipping it, heat exchanging for 10 years now. They know more about it than pretty much anybody else, and their press releases that you always see and no action.
Cool.
But thank you. Good intentions.
Thank you.
I have two questions. Not two questions. One remark about measuring containers. It's a very, very tricky area. And take those numbers are indications. If you look deep down on what you're actually measuring, because of the components architecture, when you use a certain set of instructions, you light up a part of the CPU. But if another process needs that part, you don't have twice the cost. So actually all the initiatives I've seen so far, maybe there's one I'm not aware of, and because of IP of actual CPUs and computing components, you can have something that it's 100% true, but that's the best we can have today. So if we, as an industry, could think about that, it might be relevant. But so far we've asked those questions ourselves because of the CSRD and that kind of stuff. And it's really a tricky area. So be very cautious about the metrics you expose around that, because I've started seeing people using the, exporters saying these applications generates that amount of CO2. But actually, if you are really not nitpicking, but very strict about the meaning of words and what you were giving as metric. It's kind of an estimation. It's never something exact, and that's what part of the problem actually. Just a remark.
If I may, on this topic,
Yeah.
Typically on a hair-based systems, no one is considering the farm power consumptions,
Yes.
which represent 100 of watts.
Yeah.
Who am I distributing this power to which container? Good question. And no one does this type of stuff. And so for the power consumption of DIMMs, of storage, of network cards, and by the end, they are only consuming the power CPUs, and for given everything else, which is more than the processor itself. So by the end, this is our assumption that most of this distribution from containers to CO2 is broken because no one considers the system as a whole.
Cloud access.
Just have one question about your design, the cubes. I'll call it like
They're
that.
boxes, we call
Yeah.
them boxes.
Do you intend on, I don't know, sell it as a product, or do you intend it or as a something like an open standard for the industry? I don't know, how do you see it for in the future? Because I don't know, I'm not the data center guy here, but maybe we want to discuss that with you. And so maybe.
Yeah, so it's not our business as well. So we threw some energy into this, some engineering, but we also partner with a small startup. They're called Diggers. They're in Austria, so I can connect anyone with them, and they are our partner in this venture. But I just wanted to explain the concept of, okay, let's do it, but do it 100%, and then eventually roll back a bit if it doesn't work at scale. But that was the initiative, and if it can become a standard, why not? But I think we're too small to impose that.
First, a small remark. I had seen those negative pressure DLC things, and it's really cool. I didn't know it was already used in production, so congratulations. Maybe I'd like to know more about that. We can discuss that. But first, I'd like to go back to Cloud Access. You're saying you're already exposing that to your customers, so they know their CO2 consumption, depending on their services and what they deploy on your platform. Have you seen customers trying to gamify the system, trying to go into the data centers that eat less CO2, for example? Or changing hardware specifically or instance types specifically for gamifying this aspect?
Not yet, because we're, again, engineers, so we're very cautious. So today it's like we're launching this. It comes after the fact. The one thing that we don't have, for example, that every other cloud provider has is a calculator. We don't have a carbon calculator on our website. And I don't plan to have it until, I don't know, maybe next year. It was like, okay, let's give the raw data first and see how customers react, and also the first value that we have, they are not great. I'm not proud of the values, but at least they're there, and now it's only about improving and having also our customers improve with us, because they're a big part of that. If they use more wisely, cautiously, if they stop things at night or whatever. Not good for my finances, but still, it's for the planet. It's overall better.
So I have another question. Since you say you're not proud of the data, aren't you afraid that by going there with an engineer mindset, you're giving them the raw data, and it might be closer to a good estimation, but your competitors are not doing that. They're doing back of the envelope math.
They will. I mean,
yeah, but
they'll have to.
Some customers will look at the numbers and say, okay, Exoscale is not that good on CO2, but your competitors are not doing anything better.
I don't care.
Okay.
Yeah.
Congratulations.
No.